Good morning, students. Chapter 6, Electromagnetic Induction. What is electromagnetic induction? Yes, we have discussed after numbers of experiments, scientists suggest that due to change in magnetic field star, current is produced in coil. Now, how current is produced? We will see one concept before how to understand experiments performed by Faraday. Magnetic flux. What is magnetic flux? You know what is electric flux. Electric flux is defined as numbers of electric field lines cutting surface placed normal to it. Similarly, here magnetic flux is defined as numbers of magnetic field lines cutting the surface held perpendicular to it. Okay, so yes, here as we have defined electric flux, in the similar manner we can define what is magnetic flux. If it is uniform magnetic field, if it is uniform magnetic field B, uniform magnetic field B, one plane is placed like this. Okay, suppose its area vector makes angle theta. Suppose its area vector makes angle theta with this magnetic field, okay, then magnetic flux passing from surface, or magnetic flux linked with this surface, phi is equal to, it is B dot A, or phi is equal to, it is BA cos theta. Phi is equal to, it is BA cos theta, where theta is angle between A, that is area vector, and B, that is magnetic field. Again, phi is equal to AB cos theta, it is BA cos theta. Okay, then yes, similarly we can use concept of area vector. That is, area vector is always perpendicular outside, normal to surface. It is always normal to surface. Yes, this equation of flux is for uniform magnetic field. If we are given non-uniform magnetic field, and we are given one surface, for example it is like this, then how to find flux passing from this? So simple. First of all we have to take elements. Find flux for first element, find flux for second element, similarly find flux for each and every individual elements, and then find total flux. So how to find the total flux? The total flux passing from surface. That surface. Phi is equal to, it is integration B dot D. Clear about this? So yes, it is equation of flux. Now I will again write equation of flux. Magnetic flux. Phi is equal to B A cos theta. B magnetic field. B magnetic field. A area, and it is angle between A and B. So how this magnetic flux changes? Yes, if there is change in magnetic field, if there is change in area, or if there is change in angle between A and B. Yes or no? Yes, if magnetic field B changes, then yes, flux changes. If there is change in B, phi is also changing. there is also change in phi. Second, if there is change in A, okay, then also there is change in phi. Okay. Third case, if theta, that is angle, changes, then yes, also there is change in flux. There is change in flux. Clear about this? Clear about this? So yes, this magnetic flux is important quantity. That magnetic flux is important quantity. Okay, phi is equal to this V A cos theta. If magnetic field only changes, there is change in flux. If area only changes, there is change in flux. If angle between A and B only changes, there is change in flux. If this all quantities changes, then yes, there is change in flux. Clear about this? Now, with respect to this magnetic flux, we will try to understand experiments performed by Faraday. We will try to understand experiments performed by Faraday. Okay, how to understand these experiments? We will again repeat that topic. Okay, how to understand experiments performed by Faraday. See, what is first experiment? First experiment, one coil. Yes, it is one coil which is connected with galvanometer. It is one bar magnet, North Pole. Here it is South Pole. Yes or no? Yes. If this magnet is moving towards coil, current is produced in this coil. Galvanometer shows deflection. That is the result of experiment. Now, what is reason? What actually happens? When this magnet is moving towards coil, we know that magnetic field lines passing from this coil increases. Initially, magnet is at large distance. Okay, it is away. As it is moving towards, more and more magnetic field lines will pass from coil. Or in another way, as magnet is approaching this coil, magnetic field increases. Yes or no? Because magnetic field and distance, they are inversely proportional to each other. So as distance decreases, magnetic field increases. As distance decreases, magnetic field increases. So flux also increases. Yes or no? Flux also increases. Clear about this? Yes, as distance decreases, magnetic field linked with, or magnetic field due to magnet increases. So flux linked with this coil increases, and due to that current is produced in coil. Okay, now see, we have discussed in Faraday's law, first experiment. Okay, when it is moving towards, then galvanometer, if it shows deflection in this direction. Okay, while when galvanometer, this magnet is moving in opposite direction, galvanometer shows deflection in opposite direction. Why? Because if R increases, when magnet is moving away, then obviously magnetic field decreases. In this region, magnetic field decreases, then obviously flux also decreases. Yes, flux decreases. Means there is change in flux. During first case, flux increases. During second case, flux decreases. So opposite nature. So this galvanometer will now show deflection in opposite direction. Because change in flux is opposite. Here increases, here decreases. Clear about this? Okay. Second experiment, we can understand with the same concept. Okay. And this magnet is replaced by coil. We know that due to current carrying coil, what is equation of magnetic field? Yes, mu 0 ni a square upon 2 a square plus x square is to 3 by 2. Means that magnetic field depends on distance. So as distance increases or decreases, magnetic field changes. Due to that, there is change in flux and current is induced. Clear about this? What is third experiment? Okay, if it is one coil, connected with galvanometer. It is another coil. It is another coil. It is connected with a battery and a key and a key. Yes or no? Then yes. At instant when we close key, what happens? Initially key is open. So is there any current flowing in this coil? No. Initially key is open. So is there any current flowing in this coil? No. So is there any magnetic field produced due to this coil? No. No, because initially key is open. So yes, magnetic field produced due to coil is 0. So what is flux in this? It is also 0. Yes or no? But when this key is closed, then at instant when key is closed, current starts flowing in this coil. So magnetic field is produced due to this coil. That magnetic field is linked with this coil. See, in this case, from North Pole, magnetic field lines, they are coming outside. Yes or no? They are coming outside. So these magnetic field lines are linked with this coil. So similarly, when key is closed, at that moment, current is passing from this coil. This coil behaves as magnet, and yes, magnetic field produced due to this coil. Links with this second coil. So now when key is closed, magnetic field is not 0. So see, there is change in magnetic field, and if there is change in magnetic field, flux also changes. So there is change in flux. Clear about this? So see, in these all experiments performed by Faraday, what is conclusion? Yes, conclusion is that current is induced in coil. Current is generated in coil due to change in magnetic flux. Here current is generated due to change in magnetic flux. Clear about this? Now current induces means what? Chapter number 3, current electricity. We know that current is flowing, means there is current. Okay, it means charges are moving. So to bring that charges in motion, we have to provide some EMF. Yes or no? For current, we have to provide some EMF. So here, as current is generated, we can say EMF is induced in coil. We can say EMF is also induced in coil, because if EMF is induced, then and then current is generated. Clear about this? Yes, galvanometer shows some deflection. It means current is flowing, but for current to flow charge, we need some electromotive force, that is EMF. So here, yes, we can say here, due to change in magnetic flux, EMF is induced in coil. Due to change in magnetic flux, EMF is induced in coil. Such EMF is called induced EMF, and such current is called induced current. Clear about this? So yes, it is how to understand these experiments performed by Faraday. Clear about this? So yes, magnetic flux, it is this point is extra, because you have to remember this. Okay, how current is generated. So you have to remember this. Current is generated due to change in magnetic flux. Due to change in magnetic flux EMF is induced, and due to that current is induced. Another result. See, if you remember, if we move this magnet faster towards or away, value of current in this loop, indicated is also large. If magnet is moved faster, then galvanometer shows more deflection. Indicating more current. So what is meaning of that? More current means more EMF. So yes, here we can say that this induced EMF does not depend only in changing magnetic flux. It also depend on rate of change of magnetic flux. Rate of change of magnetic flux means change of magnetic flux per time. So with this all experiments, with these results, Faraday have one law that is called Faraday's law for electromagnetic induction. What is Faraday's law for electromagnetic induction? We will see. Now, Faraday's law of electromagnetic induction. What is Faraday's law of electromagnetic induction? Yes, Faraday, after numbers of experiments, proved that magnitude of induced EMF in circuit is equal to rate of change of change of magnetic flux linked with circuit. Why this time rate? Remember that point. When magnet is moved faster towards or away from coil, galvanometer shows more deflection, means more current is produced, means EMF is also. Clear about this? So yes, here magnitude of induced EMF in circuit is equal to time rate of change of magnetic flux linked with circuit, and it is indicated by E, average EMF. How to find average EMF? Is equal to, it is minus delta phi upon delta E. Here it is average induced EMF. Here it is average induced EMF. Okay, what is instantaneous EMF or only induced EMF? Induced EMF E is equal to, it is minus d phi upon dt, where negative sign indicates, here negative sign indicates direction of induced EMF. Now you may ask, why this EMF word is used? We have proved in experiment that due to relative motion or due to change in magnetic flux, current is produced in coil. What is source of producing current? EMF. So current is produced, it means its source, EMF is produced. So that's why we have to find EMF. So Faraday's law of electromagnetic induction, that is magnitude of induced EMF in circuit is equal to time rate of change of magnetic flux linked with circuit. Average induced EMF minus delta phi upon delta D. Induced EMF is equal to minus d phi upon dt. Negative sign indicates direction of induced EMF. That we will find with the help of Lenz law. Okay? Yes, we will see in next theory. Okay, now T is equal to this minus d phi upon dt. It is only for one circuit. If circuit contains n identical identical terms. Then what is flux? Then total EMF. Then total EMF induced. Then total EMF induced. E is equal to, it is minus n d phi upon dt. It is minus n d phi upon dt. So yes, it is Faraday's law of electromagnetic induction. It is statement, it is equation. Clear about this? Now, from Faraday's law of electromagnetic induction, we will get magnitude of EMI. We will get magnitude of EMF. Okay? From Faraday's law, we can find magnitude of induced EMF. We can find magnitude of induced EMF. Okay? So yes, this point we have to remember. From Faraday's law, what we can find? We can find magnitude of induced EMF. We can find magnitude of induced EMF. Clear about this? Okay? Now, in next lecture, in the next session, we will see, okay, how to find direction of induced EMF. How to find direction of induced EMF. Faraday's law of electromagnetic induction gives only magnitude of induced EMF. But how to find that direction, that we will see in next lecture. Yes, students, this electromagnetic induction is one important topic. Because in regular life, some appliances which are used, they have this concept, that is electromagnetic induction. So yes, what is concept of electromagnetic induction? EMF is induced, current is produced in coil due to change in magnetic flux. Now you remember that star. Not due to change in magnetic field, due to change in magnetic flux, EMF is induced, and due to that current is generated. Clear about this? So yes, in the whole chapter we have to do one thing. Due to change in flux, EMF is induced, current is produced. Simple. Okay? So yes, it is chapter number 6, electromagnetic induction. I am Asif Mundra, your physics teacher. Watch videos regularly, make your notes regularly. If you have any doubts, then solve your doubts. Try to solve your doubts. Okay? And yes, do like, share and comment our videos, and especially mine. Okay?